Hi everybody, this is Module 5, Lesson 4. We are calculating probabilities for chance experiments with equally likely outcomes. So the essential question is, how can we calculate the probability that an event will occur? So this is not using data. It's just saying, if I know that this is the setup for an event, what is the probability that the event I want is going to happen? So in this first one, we're actually going to do this tomorrow in class. I'm going to do this for you guys so that you can kind of see what happens. And I'm going to have a bag. It's going to have some yellow, some green, some blue, some red. And then I'm going to pull out and replace 20 times. So I'm going to pull it out. We're all going to write down yellow, red, blue, or green. And then put it back in and then pull out another one, yellow, red, blue, or green. And based on the results, we're going to predict, like, okay, how many do you think there were of each? All right, and then on the next page, it's going to say, based on the 20 trials, we're going to record how many of each there were, each color. And then if there were 40 cubes, how many do you think there were of each color, that kind of thing. So we're going to be doing that together in class, and that will take about 10 to 15 minutes. So we're going to set aside some time in class just for that. Okay, so what we're going to do is flip to page 28. And we're going to define theoretical probability. Theoretical probability. Use math to predict the likeliness of an event. Okay, how about when all possible outcomes of an experiment are equally likely? The probability of each outcome is just as likely as the other. And so to give you an example of that, we're going to draw on two things. We're going to draw the number die. We can only show 3 sides of that. So let's say here's 1, here's 2, here's 3. So how many sides are there? 6 sides. And then what if we had a spinner split into 4 sections, and we can call it A, B, C, D? Okay, so that's 4 equal sections. Okay, to determine the likeliness of each of those, it's just as likely to land on a 1 as it is a 2, as it is a 3, as it is a 4, as it is a 5, as it is a 6. It's equally likely to spin an A as it is likely to spin a B, as it is likely to spin a C, as it is likely to spin a D. So whenever we do that, whenever something is just as likely as the other, hopefully you understand what I mean here when I say each of these 6 sides are just as likely as the other, each of these 4 sections are just as likely as the other. We're going to make the fraction 1 over the number of possible outcomes. Okay, so for this one, it's 1 out of 6 for each side. And for this one, it's 1 out of 4 for each section. And all that means is it's the same fraction for A. So it's a 1/4 chance of getting A, it's a 1/4 chance for getting B, a 1/4 chance for getting C, and a 1/4 chance for getting D. Here it's a 1/6, no matter which of the 6 sides that we're talking about. Okay, so you can go ahead and circle that fraction there. That will help us when we talk about equally likely outcomes. Okay, an event is a collection of outcomes, and when the outcomes are equally likely, the theoretical probability of an event can be expressed as, we're going to call this favorable over, again, number of possible outcomes. Okay, and then this one we're going to answer in class. You can put a little IC there if you want. Okay, and then that's going to be for exercises 5 and 6 as well. All right, let's flip over to page 29. An experiment consisted of flipping a nickel and a dime. The first step in finding the theoretical probability of obtaining a heads on the nickel and a heads on the dime is to list the sample space. Remember, the sample space is all possible outcomes. So what it's saying is if you flip a nickel and a dime, you could get heads on the nickel and you could get heads on the dime. Or if you got heads on the nickel, you could get tails on the dime. If you got tails on the nickel, you could get heads on the dime, or you could get tails on the dime. So there's 4 possible outcomes. If the counts are fair, these outcomes are all equally likely. So the probability of each outcome is what? There's a 1 out of 4th chance we'll get heads with heads. There's a 1/4 chance that we'll get heads on the nickel and tails on the dime. There's a 1/4 chance that we'll get tails on the nickel and heads on the dime, and there's a 1/4 chance that we'll get tails on the nickel and tails on the dime. So each one of those has a 1/4 chance. So what's the probability of 2 heads? That's right here. Is 1/4. Or the probability of 2 heads is 1/4. In fact, I want you to write it like this. This is actually how you're going to see it. Heads, comma, heads. That comma means heads on the first and heads on the second. Okay, and those all equal 25%. Okay, it's also 25% chance for any of those. It's just that they asked us about heads with heads. Okay, how about exercise 1? What is the sample space of rolling a number cube? So consider a chance experiment of rolling a number cube. What is the sample space? List all the possible outcomes. Okay, go ahead, pause and do this on your own. Okay, if you're all done, did you get 1, 2, 3, 4, 5, 6? Those are all the possible outcomes. Okay, so what's the probability of rolling an odd number? Well, which ones are odd? There's 1, 3, and 5. Okay, so 1, 3, and 5 are the odd numbers. So that's 3 out of 6. In fact, let's write it out. 3 out of 6 sides are odd. So then we're going to write 3 over 6. And then if you reduce that, that's 1/2. Sorry, I'll email you. Okay. All right. Okay, and then on the next one, it says, what is the probability of rolling a number less than 5? How many numbers are less than 5? We have 1, 2, 3, and 4. Remember, it says less than 5, not equal to 5. So that means, 4 of the 6 sides are less than 5. So we would write 4 over 6 and then go ahead and reduce that. Okay, so 2/3. All right, how about exercise 2? Consider an experiment of randomly selecting a letter from the word number. The word number. The word number has N, and then it has U, and then it has M, and then it has B, and then E, and then R. None of those repeated, so all 6 of those are different. And then each one of those, each letter has a 1/6 chance of being selected. Okay, what is the probability of selecting a vowel? Which ones of those are vowels? U and E. Okay, you go ahead and try this on your own. Make sure you tell all your friends to listen to the videos, because there's a lot of people that are going to miss stuff if they just watch and don't write. Okay, pause and try this on your own. Okay, if you're hearing this, then hopefully you wrote 2 out of 6, which is 1/3. That's a common fraction, so it's going to be helpful for you to write this so that you see it. This is the same as 33 and 1/3%, or 33.3 repeating percent. Okay, try this one on your own. What is the probability of selecting the letter Z? Okay, why did I put a question mark there? There are no Z's. It is a 0 out of 6 or 0% chance. Okay, hopefully you got that one right. All right, for exercise 3, consider an experiment of randomly selecting a cube from a bag of 10 cubes. So we know that there's 10 cubes. Let's color them so that the probability of selecting a blue cube is 1/2. 1/2. Okay, and it doesn't say what the other colors are, so you can make them all one color. You could even make them different ones. But half of them are blue. Okay? Half of them, 5, are blue. Okay, now let's color the cubes to the right so that the probability of selecting a blue cube is 4/5. Okay, pause and try this on your own. And if you're not sure how to do 4/5, so I gotta move this over here. Well, then count 5 and just do those ones first. So you could even section it off and say, okay, here's 5 cubes and here's 5 cubes. Okay, so color 4 of those 5 blue and then 4 of those 5 blue. Okay, hopefully you paused it and tried it on your own. And let's see how you did. Did you color in a total of 8 blue cubes? Hopefully you did that, and then I'll color these 2 yellow. Okay? So 4/5, which is 8 out of 10, are colored blue. Okay, not too bad. This last one, we're going to talk about what this means. The sample space for this game. Students are playing a game that requires spinning the 2 spinners. So you have to spin the 2 spinners. That means both. Okay, list the sample space. Well, if I spin this spinner, I could land on blue or I could land on red. Now, if I spin the next one, I could land on blue, yellow, green, or red. It's not 6 different options though. Because the first one was blue or red, the second one could also be blue or red or green or yellow. So let's pretend that the first one was blue. If the first one landed on blue, the second one could also land on blue. But if the first one landed on blue, the second one could have landed on red. Or it could have landed on yellow. Or it could have landed on green. So if the first one is blue, the second one could be also blue or red or yellow or green. That's 4 different options if I land on blue first. Okay, now what if I landed on red first? If I land on red first, I could land on any of those other ones. So I'm just going to leave it there so that we can still see that. But if I landed on red first, I could land on red on the second spinner, or I could land on blue on the second spinner, or I could land on yellow on the second spinner, or I could land on green on the second spinner. So that's all my options. So there are 8 options total. Okay, so that's 8 possible outcomes. A student wins the game if both if both spins land on red. What is the probability of winning the game? Well, if you notice here, this is the only one, and they're all equally likely, so it's a 1 out of 8 chance. Okay, you can save the summary for tomorrow since we're going to finish this one up in class, and that is a wrap on lesson 4.